Hi everyone, good afternoon. Welcome to Meeting Electromagnetic Challenges in High-Tech Automobile Design webinar. We will begin the session by a brief introduction of the speaker, Mr. Yogesh. Welcome, Yogesh.
Thank
Yogesh
you.
is a engineer at YS3D. He has more than 5 years of experience as an RF engineer. He worked as a RF design and antenna and radome designer in different industries in his career. He has completed his MTech from IIT DNM Kanchipuram in the Communication Engineering branch and BTech from MIT Aurangabad and is currently pursuing PhD from VNIT Nagpur. You all are free to ask questions to our speaker. You can write them down in the chat box and we will address them towards the end of the session. Over to you, Yogesh.
Thank you, Pradnya. Am I audible perfectly?
Yes, you are.
My slides are also visible, right?
Yes.
Yeah, thanks. Yeah. So today's presenting topic is meeting electromagnetic challenges in high-tech automotive design. Uh, so I would like to start with our company overview. VS 3D capability starts with engineering consultancy, where we provide a product from the concept to the demonstration and decomposition. We provide best-in-class software solutions. Considering the training, we provide intelligent, insightful instructions. Talking about automation and customizations, we provide parametric and non-parametric optimizations. We are the gold partner of Dassault system. We are located at United States, Canada, Mexico, India, and currently we are in Turkey as well. Extensive industry experience. We are into aerospace and defense, automotive industry, energy, process and utilities, industrial equipments, marine and offshores, life science, including medical devices and high-tech industry. Our expertise includes mechanical and electrical design, digital product simulation, digital manufacturing, product life cycle, and management. Currently, our team is more than 100 employees, with 20 are the PhD, 40 are MSc and MTech specialists in different areas like designing, manufacturing, structural mechanics, fluid mechanics, electromagnetics, optimizations and reliability, data analytics, systems, hardware, and architecture. So now we can start our today's main topic, electromagnetics for high-tech industry. Before that, we can see what do we mean by high-tech. In most of the application, if you see like automotive vehicles and mobile, behind all the connectivities is due to the electronics and RF connectivity. We first of all see recent trends to think of high-tech as a relative new technology or cutting edge technology. Perhaps also something gives a product new and desirable capability, something that not commonplace or commodity. What is high-tech tends to evolve quite rapidly. If you recall, the satellite vehicle radio was considered the high-tech industry about 10 years ago, and now if it looks like pretty dated in low technology compared with its music and recent streaming and all. From the internet, similarly, products with many buttons and lights used to be sounds of all. So known high-tech industry and advertise themselves. Now the high-tech must hear much more about the behind the scene of the software that controls it's some modern electronic devices. And if you see the car dashboards also, for example, that are much more minimalistics and having capability enough are not so obvious from the first glance in the automotive fields of the, we can say, an electromagnetics and all. So if we talk about the mechanical also, the or considering electronics also there, the mechatronics, which covers many of these backgrounds, which covers many of these backgrounds type of electronics and software systems. If you see, uh, it's been estimated that up to 90% of the current automotive innovations is driven by the electronic softwares. That means that the R&D teams at automotive OEMs and their suppliers need to have a very strong high-tech focus. As we go through this presentation, we will look at some of the rapid development vehicle high-tech areas and associate challenges, particularly due to the electromagnetic phenomena in such complex and regular systems. Additionally, we will also look at some of the physics behind the simulation, that is what we are discussing CST as well, can help us for resolving the challenges earlier in the design process and provide path for the greater innovation. So back to specific challenges of high-tech innovation and why is electromagnetic is so important here we can see. If you see this ADAS, which is Advanced Driver Assistance System, connected cars, vehicle to vehicle, vehicle to V2I, we can say 5G, talking about cable harness also, where most of the car consisting of a kilometer of length of the cable inside that. So to analyze cable harness, which is a backbone of a vehicle or a communication network, which speed, talking about cabin also coverage, co-side and safeties, control system, actuators, and associate systems with the high-speed PCBs and ICs. If you see the automotive thing, in this presentation, I will concentrate on the hidden challenges and champions which are there in the vehicle. Those systems that think and are linked together with the sensors and electronics and control units that provides the functionality for our entertainment or the comfortness, and that makes the electrical drive possible at all the locations. If you see this high voltage and power distribution, high speed Ethernet with electronic control units and wireless communication systems. So most of the vehicle, if you see in the same next one, where the most of the equipments are due to the electromagnetics. If you see the electronics also, it will be there. If you say here in this example where you can see for connectivity, multiple cables are routing inside a car, which will go from a particular one system to the other system for the communication. So it is very much essential for us to do the cable harness study. As we know, inside a car also multiple antennas will be located at different location. As we have seen, V2V communication, vehicle to vehicle or vehicle to anything communication, which is possible with the help of antennas, which is due to antenna placement. If you have to navigate it, we have to communicate with the satellite and all. Talking about the PCBs and electronics which are there inside a car, so we need to do the analysis of PCBs and relative components, and mostly what we have for electric vehicles are the battery management systems. So now talking about electric, connected and autonomous vehicles, one of the big trend we see for the future automobile is ECAV, ECAV, or the electric, connected and autonomous vehicles. These are the three high-tech areas that the OEMs see driving their business in the future. The coming for both the consumer demands, but also if you see the regular environments also. Some examples are shown here where the fuel efficiency standards are increasing. They're requiring the manufacturing to include electrical vehicle, which are there in the lineup. Consumers are really starting to like electric vehicles due to their comfortness, efficiency, and ease of charging now. The autonomous and connected cars will bring the safety benefits, but it also bring the promoted by their high-tech interested, such as the ride-hailing services and all. So connected vehicle will also allow the plotting and autonomous vehicles, warning to the following vehicles, remote operated drivings. So these are the things can be seen. Talking about electronics, now will soon the primary cost driver. Let's consider a few other statistics. This chart shows the current and estimated future share of electronics in the total cost of the automobiles. You can see that not only in high-tech driven innovation, but increasingly the cost of new vehicles as well. If you see the business drivers and the challenges, the modern vehicles are being mobile high-tech appliances. If you take any examples, we need to go for all the analysis and all. If you see this electrical, connected and autonomous vehicles, the quality, cost and regulations, new customer experiences and all, where the rapid development in high-tech industry and their applications are coming into the picture. The automotive grades deliver is one of the thing again. And talking about new regulations, uh, the customers also, the new customer expectation which needs to be satisfied with the hardware devices or given answers by the softwares. Talking about industry process experiences and electronics, one of these industrial process experiences deals with the development of electronic devices. The goal is to set the system running the first time right with virtual prototyping and analysis of the power electronics, signal integrity, and EMI EMC, electromagnetic interference and compatibility. With the rules-based design check, it is possible to avoid error on a printed boards upfront. So whenever we are going to do the analysis of this electronic equipment, for us to be primarily basic rule to go for the design rule check. So electromagnetic software provides this at in front of the first stage. Simulation supports uh, also to optimize the power delivered networks and to predict the reliability of high speed communication channels. There is a number of other industrial processes which experience that deals with the cabin comfortness as well. Talking about example of a car also, where we have the ADAS sensors which performance connected vehicle communication, doing electromagnetic interference and compatibility and analysis. As we have seen the number of cables going through inside a car and all, so the cable harness needs to be undergo for the simulation. Next, talking about the electric drive and power electronics. A high voltage, high power, and pulse width modulated signals plays a significant role in the electric vehicle. The heart and brain of electric power drain system must be precisely controlled by the power transferred between the batteries and electric machines. And also it is implemented to logic and adjust the powertrain to the various delivering conditions and the driven inputs. To operate under a variety of driving conditions, power supplies to the motor needs to be carefully controlled at relatively high switching frequency. As we know, the frequency of operations will be high. So while switching that, we need to be very much careful enough to do that. This also accomplished through the services and the devices such as the IGBTs, insulated gate bipolar transistors based on the position, speed, and the temperature. Electromagnetic interference and compatibility, that EMC is a main concern because the relatively high switching frequencies, it directly affects into the compatibility and interferences. So EMI may perturbs the signals and prohibits the motor from the proper operation. Therefore, a comprehensive study of the electromagnetic fields in and around the motor is required, including, if you see the bus bars also, bond wires, and the nearby RF and electronic components. while these components are operating in an unconnected and coupled way. So both components and the devices, it's not like always been connected through some conducting elements. Maybe due to some radiative effects also, or the radiative connections will also be there for the devices. The electron mobility also requires the converters and inverters. If you see here, the voltage from 400 volts to up to 800 volts is there. A typical component used for electric vehicles is also one of the inverter. It transforms the direct current of the battery into the sinusoidal three-phase signal that drives the electric vehicle. If you see the cabin comfortness of IPE, so here one of the video is there for cabin comfortness.
Michelle and Bob are senior design engineers at Blue Motors, a company known to produce cars with really good cabin comfort. Modern car comprises of 4 prime aspects: thermal comfort, acoustic comfort, interactivity, and seating comfort. Comfort is at the core of human experience. Michelle and Bob have been working on designing a car with a cabin comfort that sets their brand apart with a delightful customer experience. Today, they are taking the blue car for a spin from Sierra Nevada to Death Valley. The road trip from Sierra Nevada to Death Valley presents an exciting array of climatic conditions varying from very cold regions in Sierra Nevada to extremely hot regions in Death Valley, cutting across national parks and barren and desolate lands. Designing the cabin for a modern car presented tremendous challenges to the company. The considerations were to design a car with a long range, manage the overall vehicle energy, provide comfortable riding experience, defrost demist with WLTP regulations. The objective was to design an energy-efficient and safe cabin for a delightful customer comfort experience. The considerations were time to comfort, battery range, quieter cabins, seating posture, thermal and acoustic performance, seamless electronic connectivity, and user experience. Engineers must rely critically on simulation and optimization to achieve these tasks. However, for manufacturers to remain competitive, it is no longer good enough to rely on a complex mix of legacy simulation tools from different vendors based on different incompatible technologies, and file formats requiring complex error-prone exchange of data from one system to another. Bob and Michelle adopted the 3D Experience platform as it delivers the solution required to resolve this challenge. This platform provides dashboard, SPIM for communities, messaging, collaborative tasks, notifications, 3D drive to manage files on the cloud. DAS Alt Systems provides an end-to-end solution to design all aspects of cabin comfort. The 3D Experience platform enables to build multiple simulation workflows on a single master model.
Bob, the defrosting took just less than 18 minutes. Several design iterations were done quickly on the 3D Experience platform to achieve the best vent design.
Michelle, we have a state-of-the-art infotainment system and onboard electronics. The designers have ensured a top-notch occupant experience delivered through excellent compatibility between the electronic devices with no cross-interference. Oh yes, Michelle, the seat design team has tested multiple seat variants to provide a best-in-class posture comfort with improved lumbar support and pressure distribution over a larger cushion area.
Bob, I am really hungry. Can we stop and get something to eat?
Sure, Michelle, let's stop at the Furnace Creek Visitor Center. They have a good restaurant. Since the temperature is high here, by the time we will come back to our car the interior could be very hot.
Our advanced reflective coating on the roof should keep the interior quite cool.
Michelle, the bad water basin is a good place to try out the functioning of our HVAC system. Normal HVAC systems could really fail here due to very high temperatures.
Bob, our HVAC system is incredibly robust and quiet.
This is great. We have reached Death Valley in a single charge.
So if you see with the help of this 3D experience and all, with the help of the 3D experience and all, how much we can say analysis can be done with the help of that by checking the coolingness of the car, what would be the next destination, where to park the car, where will be the efficient way of keeping a car, comfortness, trace analysis, train analysis, the position of a customer or position of the driver, and a comfortness of the driver, what would be the points to be analyzed. So all these things can be done with the help of the 3D experience and electromagnetic tools. So if you see the electromagnetic applications, this is what the pie diagram will come across. Started with micro RF and optical, then we have EDA and electronics, then we have EMI, MC, particle dynamics, static and low frequency. So depending on your application, we can select our studio suits and all. If you talk about the application individually, so micro RF and optical, so therein you can design all types of antennas for high-tech industries, component required, the calculation of RCS, if it is for defense, then on-body application as we embed with multiple antennas and variable devices when we drive or do any application type of thing, considering a car also. Then talking about a PCB, we can do all EDA electronics and EMI MC analysis, wherein you can do signal integrity, power integrity analysis, a core simulation with SIPI, radiated and conducted emission, radiated and conducted susceptibility. And as told, so at the initial stage of a PCB analysis, you can go for the design rule check and PCB rule check. If we are new for PCB analysis, this is very much important for us, where to check the signal integrity, power integrity, and EMC rules. So whatever PCB has been imported by ourselves, whether it is violating any rules regarding this SIP and EMC. So all this can be at initial stage only verified from our end. Talking about the importing facility, electromagnetic supports, talking about 3D exchange format. Talking about 3D exchange format, all the steps at IGS, STA, and OBJ can be imported inside the tool. Talking about 2D exchange formats, all DXF, Gerber, ADS, and SONET can be imported and exported. Talking about PCB, mostly we import and export ODB++ format, so it also supports that. If you're working away from that, like Cadence, Allegro, Mentor Graphics, and Zuke, through that we also directly communicate with that. So all on-body applications can be done it because of the voxel family and voxel data available inside a CST library. So you can import any phantom also, and you can do real-time simulations, as we have seen that video where stress and strain analysis of the comfortness of a person when he sits on a car. So that body can be imported, or the 3D structures of it can be imported with the help of this phantom model. Talking about MCAD files, the 3D native files, so with the help of mechanical tools like Pro, CATIA, Aston, and Autodesk, Solid Edge, Parasolid, and SolidWorks. So with the help of this, you can import any MCAD files also in electromagnetic analysis. Yeah, talking about connected vehicles, if you see the modern cars are complex electronic systems. If we look behind the scene, there is a huge number of sensors, actuators, and electronics which are placed inside a car. And there are many antennas, different antennas, and you can see at different antennas will be there inside a car. So to simulate it, we can do the analysis as well. Talking about connectivity and vehicle to vehicle, where on-body persons can be inputted, and further the analysis or effect of the antennas and electronic equipment can be checked on the human body. Here an example of an antenna which is placed on a car. It has been shown. As we have seen, there are a number of antennas are there inside a car, like for Bluetooth, for GPS, for navigation, and all. We are having different antennas. So in real-time environment simulation, we can do that one also with the help of a placement scheme antenna which is placed on a car. Talking about the ADAS radar and detecting things, what we have like automotive radars which is operating at 77 gigahertz. So all these can be analyzed here in electromagnetic tool. Talking about the wireless charging, so where we know that the operating frequency of this is in hertz and kilohertz at very low frequency. All this can be analyzed here inside electromagnetic tool. For static induction charging also, you can see here example for charging a car with the help of the magnetic coils. So that can be seen here, like how much effective our charging station is there or our device is there, that can be also checked. And whether that charging device is which is harmful for our body or not. So harm to occupants like the drivers or a person who is sitting at nearby the charging device. So on-body application, we can see that can be also checked it here, and which is necessary component of it. Then talking about EDA, electronics, and EMC related to high frequency, all the signal integrity, power integrity, and EMC simulations can be done and analyzed here. Talking about the signal integrity, power integrity, and EMC, we will start with signal integrity issues, where if you see, just a minute. So if you see the signal integrity issues, all the ringing field, crosstalk, distortion, signal loss, and power supply noise, all these can be analyzed here. And we have shown here the end-to-end communication system, where you have the PCBs, the touchstone models, IBs model, the SPICE model, and all. So where we can see whether our total communication system, how it will behave when we talk about the signal integrity simulation. So, and an example is shown, like why we use equalizer and clock recovery signal. If you check the response before clock recovery signal and equalizer, you can see how much distorted eye diagram we can see here. Once we use the equalizer and clock recovery signal, we can see that perfectly we have recovered our transmitted signal, or our eye diagram is perfect. So that type of analysis also we can do it here. Talking about power integrity analysis, which deals with the power delivered between the power sources and the active devices, and the issues like the simultaneous switching noise, ground bounce, high impedance, and resonance can be done and analyzed here. The quick glance at the impedance curve, we can see it here after simulation. After simulation shows that at different frequencies, we can see here there is a threshold breakdown is there, or we can say like high impedance been seen here. So that type of, with respect to frequency analysis, can be we can do it here. And if we talk about high intensity fields, with the help of this color identification, we can see that the red color indicates the high intensity, and that can be checked it here in the tool. Talking about EMC issues, all the imbalances, time screw, common mode current, conducted and radiated emissions can be checked it here. Yeah, one of the important thing for whenever we import a PCB is the design rule check. So talking about signal integrity, power integrity, and EMC rules, all can be checked at the initial stage itself. So whenever we are going to import a PCB, at that stage itself, with the help of the tool called PCB rule check, you can check all the rules of the PCBs. And if there are any violations are there, very much quickly we can just check whether the violations are there. Whatever it is obtained, you can see in a dash and dot lines that a particular violation component will be displayed here. Then again, you can just rectify the issue, and again fastly you can simulate it again, and you can just avoid that particular rule violation. Talking about conducted and radiated emission, so here an example is shown of a cable and a connector where common mode current analysis is being shown, and as the length is very large, so resonance is also can be seen here. Talking about radiated emissions, for an example of a car having electronic equipments there, so EMC radiated simulations can be checked it here by keeping probe at a different location, and you can identify how much amount of electric field is coming at a particular end. Again, talking about the use of EMI filters inside any a PCB or a system is very much essential. So you can see it here. If you are not using EMI filters, you can see the noise component of that is at very high peak. And when you do the EMI filters activated, you can see that we are working on the reduction in the noise level. So all this can be done it here. Talking about the EMC simulation, here one of the example is shown, which is a DC to DC converter, which convert 12 volts to 5 volts supply. You can see the 3D component and schematic view of it. Here the EMI filter simulation is also shown. So when we make the EMI filter deactivated, you can see how the electric fields are conducted or transferred to the unwanted areas. So we can consider this as a noise when we make the EMI filters deactivated. But at the same stage, when we make the EMI filter activated, then you can see that there is no unwanted electric fields or the current is coming out of the required path. So that type of analysis also you can do it here. Again, the hotspot area reduction is also can be done. If you can see here on top image, this red color indicates the high intensity field. So with the help of the relocation of this particular component, you can just reduce the hotspot area. Now talking about the drivetrain for EMC simulations. In the powertrain model, the battery inverter and motor are connected on a common ground. You can see it here on the bottom side. Ideally, the 3D simulation should be performed. However, it is very much expensive to model this 3D component, including all the details of the inverter, this model, and the battery. To simplify the model, the battery and the motor here in the geometry are ignored, and they are represented by their characteristics impedances in the simulations. You can see it here. Ignoring the geometry details greatly we can save the simulation runtime also without losing the too much physics behind that. In this model, the inverter is modeled in the 3D environment details. The inverter is a simple three-phase H bridge inverter, and you can see at our required band at 1 kilohertz, you can see the current distribution where it is at high end, which is perfectly traveling. But if we talk about the noise level also, we can see it here where the noise level is generated at high frequency at 1 megahertz. So this also can be very much easily find out. And again, the same thing with the use of the filters. If you are not using filter in a particular design, you can see the noise level is at very high level. And if you make the filters activated or with filter, you can see the noise level has been reduced. Then talking about the analysis of the connectors and the cable, all the conducted emissions can be simulated here with the help of a PCB. If you have a PCB which has been connected with a cable, both simulations can be done it in a single environment. So you can see it here, this PCB is been connected and some transmission lines are coming out. So if you can see this cable wound also, you can see there are different cables are traveling from this line, where some of the cables are the power cables, some of the cables are the communication cable, but still all these can be simulated in a single environment itself. So cable with a PCB can be simulated, and with a connector and all can be simulated. You can see in a schematic view, you can import all the components schematic like a connector and a cable and all, and you can do the further simulation. Like if you want to do a TDR simulations, you can see it here on the bottom side, it can be done. And mostly what we say for a resonance is the scattering parameter, so that can be also done it here. Mostly what we say for a cable is the insertion loss and crosstalk happened inside the cable. As inside hybrid cables, you can see it here where the multiple cables are going. Some of the cables are like a communication cable, like a data transmission. Some of the cables is there for the power and all. So it is very much essential for us to do the crosstalk analysis also. So you can do it here also. You can see here one of the example is been simulated from 0 to 12 gigahertz, and you can see at our required resonance at 2.5 gigahertz how much amount of the power is been there. So that type of simulation also can be done. And for a system simulations with number of connectors and cable, collaboratively effects can be seen it here. Again, talking about a parametric sweep for wire distance is very much important. So to keep the two cables to avoid the crosstalk, how much gap should be there? So by mathematics or physics, if it is unable to identify or getting some issue, so what we have is like a parametric sweep. By manually giving some parameter here, you can give instructions to the parametric sweep, and slowly you can just change the gap between both, and you can see where your optimal result is coming. Then all electronics EMI EMC performance simulations is also can be possible here in the tool. If you want to do the simulations of enclosure leakage, as we have the some of the gaps and all, again generation of the temperature on the this enclosure also can be identified. Simulations of the connectors can be done with respect to the current, with respect to the frequency, and with respect to the deformation. If your power cable is having very high power value, or the we are giving input power as very high, in that case whatever conducting elements are there, the temperature generation will be very high. So in that case, there is a chance of getting deformation of your objects. So you can do these collaborative simulations also here in CST. Then talking about the variable frequency drive 2D and 3D models. If you see for this study, the same schematic was implemented into two different circuit boards. Both the boards do use the same semiconductors and the same control system, but there is substantially a difference in the layout of the edge bridge. The good design, we can see that the design on the top offered the wide trace all at the same length in the edge bridge section, but where while in the bad design, we have only the narrow traces from the edge bridge FET networks, where the motors where the different phases have different lengths. These are main reasons why we expect the board to perform the good and the bad. Okay, and here also you can see the result is being shown for the simulated and measured result, and we can see the adequate amount of what I can say a matching has been covered here. As we know, the cable, if you see the car, take an example for high-tech industry, 50% weight of the car is due to the cable which are wounded and traveling inside the car. So to work, if you see the research currently going on is to reduce the weight of the car. And if you see most of the weight is due to the car. So most of the R&D is going on for working on the cable simulation. So main challenge again for here is like simulations of very fine geometry, cable details in the large vehicles, because there are not only the single cable which will wound through and through. There are multiple cables which are connected to each other, going radiative and conductive coupling between them. So all these simulations can be undergo, and it is necessary for us to do. So with the help of hybrid cables, pure cables, both can be considered. Then talking about the battery analysis, we can simulate the battery. Here shows a battery model which has been done it inside a CST using a frequency domain solver. The battery operates at DC we know. So however, in EMC analysis, it is important to understand the behavior in the high frequency. The battery consists of the array of the cells. You can see it here. Each cell has a cathode and an anode and a barrier. So if you see this, the proper material which are, it is very much difficult for to say like material properties that can be simplified for the each component. Each cell, if you see the which generates the 3.5 volts, a number of cells are connected series or a parallel to generate a voltage approximately around let us say 300 to 500 volts, and a current more than 100 ampere. Emission is mainly caused by the capacitive coupling of the housing and inductive effect of the wire. The configuration of wire and housing of the battery greatly affects the emission. So we have to consider all these into the picture when we do the analysis of that. Then if you talk about the wireless communication and 5G trends and the challenges. So if you talk about the technical trends, you can see all these are divided into 4 different things, where if you see the first one, which is smaller form factor for everything which is connected, like if you see a smartwatch which has been connected with the mobile, going inside depth of the mobile, you have the high data rates and low latency and reliability devices. If you whenever we design a PCB which has a dense PCB and packages things, number of components are very much closely in a vicinity, which result into conductive or radiative effect, which may be unwanted one. Taken an example of high-tech electric vehicle cars and all, where multiple antennas are there which are communicating with each other continuously when we drive, or it is at stop location. 5G, GPS, Bluetooth, Wi-Fi, NFC, 2G and 3G antennas and all. So talking about high tech, these all needs to be considered when we say final prototype or commercialization of the prototype. If we talk about the business challenges, the OEMs and suppliers must adopt the 5G technology to satisfy or come into the what I can say a market very quickly. Step step changes in the complexity, adding a brand new frequency range, redesigning the requirements, miniaturizing the components or the antenna sizes and all. And if you see the top technical challenges, we know that when we say a 5G frequency, if you go beyond 20 gigahertz, it will come for wave technology, component density, as we are having multiple antennas, array scaling and all. There we need MIMO analysis and beam steering capability, the high data rate as well, and autonomous vehicles. Talking about automotive antenna applications, as we have seen, the number of antennas, frame of the antennas are there inside any high-tech components and the car and all. We can see the frequency band from where it is starting, like 100 kilohertz to 10 gigahertz, and beyond that also currently, if you say in waves. So all these are there. Talking about 5G, which is somewhere at 3.5 gigahertz, and the second band is at 28 and 38 gigahertz. So antenna plays very much important role inside a high-tech industries, designing of an antenna, avoiding the mutual coupling. As if you say an antenna, again it will be connected with the PCBs, again mutual coupling between the multiple PCBs and all. Then connectivity is a key role in this automotive 5G and high-tech industries. We have seen this vehicle-to-vehicle communication or vehicle-to-anything communication. Uh, as we have seen, one of the research point also to reduce the weight of the car is first we have to work on the cable of the car. As we know, the 50% weight of the car is due to the cable which will go throughout the model. And again, with the impact of this soling on antennas and sensors, multiple antennas, so radiating and the coupling between them needs to be undergo for analysis. So with the today's talk, what are the key takeaway are like modern vehicles are equipped with high tech, thus require our high speed design, signal integrity analysis, power integrity analysis, EMI and EMC investigation. As we know, OEMs and suppliers should spend on new technology and 5G development to stay competitive. As we know, in the market, we have to be on a first, so we have to develop or adopt the new technology. If you see the electronics and 5G design, which is complex with many potential points of the failure, early stage of design exploratory ensures the optimal and complaints and the products. With these we have a solution of like a 3D experience where we can do all this type of analysis and come into the market first, adopting the new technologies and all. Also, if you see, Dassault system and VRs are offering the fast and accurate scalable multi-physics multi-scale options. If you say a PCB or system level simulation, you can do all the signal integrity, power integrity, EMI, EMC simulations. It leads to end-to-end 5G design is possible here in the tool and all. So yeah, thank you. If you have any questions, we can free to take. Yes, Pragna.
Yes, Yogesh. Thank you, Yogesh, for throwing a light upon the intricate world of electromagnetic designs. So moving ahead, we have a couple of questions from our participants.
Okay.
The first one is, can we check the radiated emission at different locations?
Yes, we can check that radiated emission as we have seen. Not only radiated, both conducted and radiated emission can be checked at different locations. For conducted emissions, you can connect the waveguide ports or the receivers at different location, and you can check the conducted emission between them. And talking about radiated emissions, as we know that radiated emissions can be at different locations. So as in the tool, we have the probes. As in measurement systems, we used to connect the receivers, but in the tool or the simulation side, we have the probe. So we can place the probes at different location, and we can identify how much amount of electric field, magnetic field is being radiated due to a particular component. We can place the probe at different location depending on our requirement, like 10 meter or 1 meter or some centimeter and all. So like that way you can just check.
Okay,
I think it answers the question. Yeah. Yes.
Yes. So another question we've received is, are conductive inks help in automotive antenna applications? Also, can it reduce the weight and improve overall frequency bandwidth of the connectivity factor?
Yes. It is done. Yeah. It is.
Oh, okay.
Yes.
So is antenna placement simulation possible? Is another question that we received, Yogesh.
Yeah. As we have seen for high-tech industries and the development here, you can also see like some electronics are there which will have the radiative element like a Wi-Fi and a Bluetooth antennas will be there in a car. So placement, as we have seen, importing facility like MCAD file can be imported and you can place your antenna. So there are again 2 to 3 ways are there of analysis of these. One is like you can make the 3D environment in real scale where it will needs you hardware acceleration and the GPU for simulation of it. And another way is like you can bring the radiation effect, means like radiative fields and a field as a source. So you can bring that result only inside the MCAD file and you can place your radiative effect and the antenna radiation pattern on a placement, like on a particular location of a car, and you can do the collaborative simulation as well.
Okay. Okay, I'm just going through if there are any further questions. Just a minute. I think those were it. We just had those couple of questions.
Okay, okay.
Yes. Okay. So I think we can conclude our session here.
Okay, yeah.
So thank you, Yogesh, for delivering such a great webinar. And we hope to conduct even more webinars with you as well. And thank you all for attending this session. We will get in touch with you, and if you want, we can share the recording of this webinar with you as well. So thank you for connecting. See you soon next time.